Okay, so this video is going to show us how to solve these 6 equations algebraically and give the solutions for the stated domains. Okay, let's get started. So by now we should be familiar with steps algebraically to solve these. So the first one, sine theta is minus a half. So we've got sine by itself. We now need to state the working angle. This is one I'd like to think that we know. We're going to ignore the negative. Okay, if you don't know it, sine of pi on 6 is a half, right? Use your table. So we're looking here, got pi on 6. Okay, so we come back, we say our working angle is pi on 6. And now we say, right, what quadrant or quadrants are we talking about? Where is sine negative, right? Sine negative is down here. So we know that that's pi. That's 0. We always come from our horizontal. Okay, so our two original solutions we've got going is going to be theta. So what's pi plus pi on 6? Okay, so we've got a whole, which will be 6 pi on 6 plus pi on 6, hence 7 pi on 6. So that's one that we've got, 7 pi on 6. And then we've got 2 pi, but we're coming back by 1 pi on 6. So if we've got 2 pizzas cut into 6 slices, that means we've got 12 slices. And we're coming back by 1/6. And so that is going to give me 12 take 1 is 11 pi on 6. So we've got 11 pi on 6. Now, do we need to show this working? No. I'm just showing you for this example, but I would expect to see the diagram, and that the diagram is labelled. We say plus k lots of 2 pi, so that gives me all the solutions possible. So if I didn't have my domain, this is how I would leave my solution, right? But we do have a domain, and we know that this is just going to be one lap of the circle or one wavelength that goes. If we didn't know that, you know, you're adding 2 pi. So with sixths, we've already discussed this, that would be 12 pi over 6. So if I add 12 pi to this one and I add 12 pi to that one, or 12 pi on 6, I'm going to be out of my domain, because 7 pi on 6 plus 12 pi on 6 gives me 19 pi on 6, and that is greater than my 2 pi here. Okay, so for this one we are done. Okay, all done and dusted. Those are my solutions, and I will even get rid of the plus k2 pi because it's not needed. I guess what I would do, if this was my answers, I would write that and therefore leave it as 7 pi on 6 and 11 pi. I just like to include that. Okay, let's have a look at the next one. Okay, number 2, got cos 2 theta equals minus a half, and our domain is now up to 3 pi beyond 2 pi. First thing we want to think about is, what does this 2 do to the graph? It makes it squishier. So its wavelength is now smaller, which means I'm going to get more solutions in the same period of 0 to 2 pi. I would in fact get double the solutions that I would get normally. So I'm expecting a lot. Anyway, we do the same thing. We get our working angle. So again, if you have forgotten, we want cos. When is cos a half? So that's pi on 3. Okay, we're looking over here. Cos pi on 3, beautiful. So come back, we say our working angle is pi on 3. Okay, we're negative again, but this time it's negative for cosine. So where is cosine negative? Remember, cosine is your x-axis, so it's negative on the left. We've got pi here, we're coming back by pi on 3, and then we're going adding on pi on 3. So therefore, notice the change here, it's not theta, it's 2 theta equals pi, a whole pi, take a third of a pi, is 2/3 of a pi, right? And a whole pi plus 1/3 of a pi is 4/3 of a pi. And we say plus k lots of 2 pi. But this is where things change a little bit. To get rid of my times 2 here, we're going to divide by 2. So we end up with theta equals, now 2 pi on 3 divided by 2 becomes 2 pi on 6. And this will now become 4 pi on 6. And you must divide this also by 2. So we now have plus k pi. Okay, because both of these can cancel down to the same factor, right, the same denominator, I'm going to do that. So this becomes 2 pi on 3, 2 pi on 6 is pi on 3, and we've got 2 pi on 3, and we want to add k lots of pi, right, until we are out of this domain of 3 pi. So again, no need to look at a calculator. So what I'd be doing is, if I'm dealing with thirds, what's 3 pi? That's 9 pi on 3. Do we agree? 9 divided by 3 is 3. And when I'm adding on lots of pi, that's 3 pi on 3. So therefore, I just go theta will be pi on 3, my 2 pi on 3, and now I'm just going to add this pi on 3, aka just add 3 to the top. So I'll start with this first one because it's that one that's the pair. So 1 pi plus 3, I will also have 4 pi on 3, and then I'll have this one. 2 plus 3 is 5 pi on 3, right? This is still less than 9, so I'm going to keep going. Go back to this pair. So what's 4 plus 3? That's 7 pi on 3. Next one, right? 5 plus 3 is 8 pi on 3. Go the next one. 7 plus 3 is 10 pi on 3, but hang on, that is more than the 10 pi. So, sorry, the 10 pi is more than this 9, so it's more than 3 pi. So that one is not in the running. Okay, so that's gone. And those are my solutions, and it's more than what I expected originally, right? So it fits with the fact that I have doubled the number of graphs that fit in that same period. So I've got lots of solutions here. Just a reminder, how can we show this on our calculator? So we go into normal run mode. We want to go options. We're going to go calc. We're going to solve n, and we type in our equation. So cos 2x equals minus 1/2. Close my bracket. Oops, don't close your bracket because we're going to pop in our domain. So we put x, 0, 3 pi. Now we close our bracket, press enter. Sure, we know we're going to have more than one solution, and there we go. You can see that those are the solutions that match the ones we had all the way up to 8 pi on 3, which is what we had. Huzzah! Okay, we're scooting along. We're off to number 3, where now we've got tan. Okay, same rules apply, but remember the period for tan is not 2 pi, it's just pi. So we've already got tan by itself, so we can go straight into our working angle. Right, tan of what is 1/3 of 1 over root 3, sorry. So we look over here, what have we got? Tan 1 on root 3, so it's pi on 6 here. Okay, so our working angle is pi on 6. We go to the quadrants. Right, I'm following our steps. So hopefully you've written them down, or you know them because you've done it so often that you don't have to bother now. So where is tan positive? So in the first quadrant, because sine is positive, cos is positive in that quadrant, and then in this quadrant here, number 3, because they're both negative. So remember, tan is sine over cosine. So we've got pi on 6 there from 0, and we've got from pi, we're coming on to pi on 6. So therefore, theta take, right, so that's your whole angle there. So theta take pi on 4 is going to equal pi on 6. So 0 plus pi on 6 is pi on 6, and a whole pi plus pi on 6 is 7 pi on 6. And here's the bit, instead of saying plus k2 pi, it's just plus k pi. Okay, we don't want theta take pi on 4, we want just theta. So how do we get rid of a take pi on 4? We're going to add pi on 4. So if you're not in the fraction mood, you can come to your calculator. I don't even bother with the pi, I just say 1/6 plus 1/4. Okay, and we get 5/12. So 5 pi over 12, and you can do the same with the 7 pi over 12. Oops, so 7 over 6 plus, oopsies, plus 1/4. We get 17 pi over 12. Now, previously, when we were fooling around to get theta by itself, right, when we had the 2, we divided by 2 here, right? From 2 pi, we divided. Do you think that we have to do that over here? We got rid of this take pi on 4, we added. Do we have to add pi on 4 to this? I hope you're saying the answer is no, because this does not affect the period. It's a horizontal translation, so it just moves it left or right, but it's not going to affect our period. So we still keep it as plus k pi. Okay, we're looking now, here's our domain, so minus pi to pi, which means this solution here is not in the game because it's beyond pi, but I'm still going to use it to get my other solution. So what I'm going to do, instead of adding pi, I'm going to subtract multiples of pi. Now, because my denominator is 12, a whole pi is 12 pi over 12. So I'm going to take away 12 from each of these solutions. And you might notice that 17 take 12 is indeed 5. So that's going to stay in the game. So I'll just write it over here. We've got 5 pi over 12, right? And then we're going to take from here, 5 take 12, so we've now got minus 7 pi over 12, and if we take away 12 from 7, we will get minus 19, and that's no good. Okay, so those are it for my solutions. Okay, that's it, done and dusted. What did we have to remember? We've got period of pi for tan, and we have to know also that when we have a horizontal translation, that doesn't affect the period. The only time that we have to divide this or change this at all is when we have a number in front of the angle, because that's the bit, the b value is what changes the period. Okay, onward we go. So what's our first step? Get sine by itself. So when we rearrange this, we end up with sine squared equals 1/2, but I don't want sine squared, I want sine. So we square root. When we square root a fraction, we square it at the top and the bottom, so it becomes 1 over root 2, which is also plus or minus. Okay, so when we square root a number, we get a plus or a minus. So that's what we're talking about. We look at what are our quadrants. Oops, before the quadrant, sorry, we need to get our working angle, which is pi on 4. So again, go to your table if you did not know that. And so what quadrants are we in now? Well, because it's plus or minus, that means it's in every quadrant. So we're adding pi on 4 there from 0. We're coming back by pi on 4. Let's write these down. So it means we've got theta. Our first one is in the first quadrant is pi on 4. In the second quadrant, a whole take a quarter is 3/4. And then in the third quadrant, a pi plus a quarter is 5 pi on 4. Sorry, that's getting a little bit crowded. And then we've got our last one here. We're subtracting a quarter from 2 pi, so that's 7 pi over 4 plus k lots of, what's our period here? K2 pi, because it's sine. That gives me all of the solutions. If we didn't have a domain, our domain is going up to 3 pi. So we can go a little bit further. So we have to rewrite all of these. Pi on 4, 3 pi on 4, 5 pi on 4, 7 pi on 4. Now we start with the first one, all right? And we say, okay, if I'm adding 2 pi. So again, because we've got quarters here, in my head, I'm going 2 pi is actually going to be 8 pi over 4. So I'm just going to add 8 to each of these. So 1 pi plus 8 is, we've got 9 pi on 4. Okay, now I do this one. 3 plus 8 is 11 pi on 4. I think I can squeeze that in. Right, if I then do this one, 5 plus 8 is 13 pi on 4, but 13 divided by 4 is greater than the 3, so that's outside of my domain. So we're done. And you can check that on the calculator if you so desire. Onward. Okay, another one here, so we're going to go sine. Let's get sine by itself. So we have sine pi over 4 equals 2 over root 3, right? We suss our working angle, right? What is our working angle? It's going to be pi over 3. If you wanted to check that, come back. And I will actually, sorry, for this one, I think I've cooked it, but you can't do this with exact answers, okay? So for this, with this one, what we're going to have to do is actually use our technology. So we go into normal calculator mode, and we will now go shift sine of 2 divided by root 3. Oops, better make sure I use brackets there. Oops. Okay, why is that happening? Because if we look at, oops, if we look at 2 over root 3, okay, that is more than 1. And remember, our graphs oscillate between 1 and minus 1. So what you're in effect asking is, we're saying here's our sine graph, or in our case root 3, right? Well, we'll do it for root 3. So here, root 3, and remember root 3 is like 1.86, right? And we're saying, well, here's 2. Where does that cut? Where does that cut the graph? And so it cannot. All right. So in this case, our solution is in fact no solution. Okay. If, let's say it was the other way around, let's say it was, let's go sine theta plus pi on 4. Let's go with 2/3. Okay, we would use our calculator. We would go shift sine 2 over 3. Didn't press the shift. Sine 2 over 3. Okay, and that is now my working angle. So my working angle is 0.73. And we do exactly what we did before, right, with the pi's, except of course we're not doing pi, we're doing 0.734. So where is sine positive? It's positive in this quadrant and this quadrant. Okay, so therefore theta plus pi on 4 will be 0.73, and this one here will be pi minus 0.73. So we can pop that on our collator. So shift pi minus our previous answer. So 2.4, I guess we should do, we'll go 2.41 plus k lots of 2 pi. Okay, and then we carry on and we'll say get rid of the plus pi on 4 by subtracting pi on 4. So we will have 0.73 minus pi over 4. So exactly what we were doing before, it's just that we're not using exact values. Okay, is that going to be, so oops, minus 0.055. Okay, and then we've got 2.41 minus pi over 4. Sensitive, isn't it? Oh, 2.41 minus pi over 4, 1.625. Okay, plus k2 pi, and we look for our domain, right? These are our two official ones, but of course this first one won't actually be one of our possible solutions because we're looking at our domain up here. Okay, so we'll have minus 0.055 plus 2 pi. So we've got 1.625, that's our first one here, and then we'll have our 6.228. Okay, and then we've got what are we going up to? 3 lots of pi. So what is 3 times pi? We don't want to go over that. Okay, so our next one was the 1.625 plus 2 lots of pi. Yep, that's still within our, so 7.908. Okay, so we just took this one and we added the 2 pi. Now we're going to go to this one and add 2 pi, and if it's beyond 3 pi, right, so if it's beyond 9.42, then we don't include it. And you can probably tell, right, it's going to be beyond. Right, so that one doesn't get included. So these are our 3 solutions. Okay, nearly done. So last one, woohoo, what's going on here? Well, a little bit dodgy. This is a tricky one, but I don't like this cos 2 theta, so let's divide. So we're going to divide both sides by cos 2 theta, and lo and behold, sine 2 theta divided by cos 2 theta, and on the other side, what's cos 2 theta divided by cos 2 theta? It's 1. You think, well, this isn't better, except what's sine over cos? It's tan. So we've got tan 2 theta equals 1. So we're going to go through, we're going to go, yep, what is our working angle? So our working angle will be pi on 4. Again, if you don't believe me, here she blows, tan of 1, so pi on 4. Okay, here. I don't know if you can see my pen moving. And there we go. So we're looking at the positive quadrants again. So hither and thither. So therefore 2 theta equals pi on 4 and 3, no, not 3 pi on 4, so a whole pi plus a pi is 5 pi on 4 plus k, be careful, remember it's tan, so it's k pi. We get rid of the times 2, so that's going to be pi on 8, 5 pi on 8 plus k pi over 2. and we're going to add or subtract that now until we get all the values that we want. So again, in my mind, I'm going, okay, because I'm dealing with eighths, what's pi over 2? Okay, that would be the same as 4 pi on 8. So I'm just going to add and subtract 4 to the tops there. And you can see we've got pi on 8 plus 4 is the 5 pi. So we're just going to add and subtract. Is this going to be part of our solution? I think not, because 5 divided by 8 is more than a half. So what have we got? We've got pi over 8. I'll pop that here. Let's hope I've left enough room. So we're going to subtract 4. So 1 take 4 is minus 3, heaps of room. And minus 3 take 4 is minus 7. And minus 7 take 4 is minus 11. That'll be more than minus 1 pi. So those are my solutions. Hopefully you got all of these answers right and you were beyond, you did it before me.